In this video, I explain how to solve the following problem involving a general annuity. The problem says, Mr. Richards intends to retire in 8 years. To supplement his pension, he would like to receive $950 every 3 months for 15 years. If he is to receive the first payment 3 months after his retirement, and interest is 5.75% compounded annually, how much he invests today to achieve his goal. So think in this problem in this way. Mr. Richards is going to retire in 8 years. So after these 8 years, and I represent it here in this timeline, after these 8 years, he's going to receive $950 at the end of every 3 months. Here we read, if he is to receive the first payment 3 months after his retirement, so I know then that he is going to receive this at the end of every 3 months. And that's going to happen for 15 years. So let's write here that it will be 15 years. So we have then a period in which we have an annuity. And there is another period at the beginning when only compound interest is working. Because he's depositing an amount at the beginning, his amount is earning interest, and after the 8 years, we are going to start an annuity. So we divide this problem in 2 parts. A part in which we have an annuity, and another part where only compound interest is working. So let's divide the problem in this way. So we are going to be working first, or thinking first, in the part of the problem where we have more information. And this is the part of the problem where the question is not. Because the question is how much he deposit at the beginning. So I'm going to start from the other part. I'm going to start from the part when we have the data. We have $950 at the end of every 3 months during these 15 years. So the idea will be this. We are going to compute the present value of this annuity. This will be the amount that Mr. Richard needs at this moment. Yeah. At this moment here, after the 8 years, or at the beginning of these 15 years. And this amount here will be the future value of this part, in which we are going to compute the present value of the compound interest part. So we have compound interest in all this, but here at the beginning we don't have payment. It's only the amount that we have at the beginning what is working and earning interest. We want to compute this amount as a present value of this period. So let's start working and computing the present value of the annuity. So this amount will be here, and we know that the formula of present value of an annuity will be this one. This is the formula of the present value of an ordinary annuity. An annuity when the payments are at the end. So we need the payment, that we call it here R. We know the periodic rate of interest I, and we know N, the total number of payments in the formula. So and we have everything. So we have that 950 is the payment. So let's write here 950 at the payment. We also need the total number of payments, and we notice here that he's receiving 950 every 3 months, so 4 times per year. So K, I'm going to notice the number of payments per year. The number of payments per year are 4, and because these are 15 years, so then N equal 15 times 4, so that will be 60. So we know N, and the only that is missing is I. This is the periodic rate of interest compounded monthly. But because we have a general annuity, actually the interest here is 5.75 compounded annually. So what we have is that the rate of interest that we have is 5.75%, but this 5.75% is compounded annually. So the number of conversion periods per year is only 1. So I'm going to take note of this, M equal 1, because if this were a simple annuity, these 2 numbers were the same, so the payments will be every year and the conversion period will be every year. But the payments are actually quarterly and the conversion period is 1 year. So what we're going to find is the rate of interest compounded quarterly that is equivalent to this rate of interest compounded annually. And for this we have a formula. the formula, I'm going to take the formula here for the I, for the periodic rate of interest compounded the number of times equal to the number of payment periods. So in this case, the periodic rate of interest compounded quarterly. So this will be the formula of this periodic rate of interest: 1 plus the nominal rate of interest divided by m, the number of conversion periods of this nominal rate of interest, to the power m over k, again m, the number of conversion periods of the nominal rate, divided by the number of payment periods in a year. In this case will be 4 minus 1. So we'll make a substitution of everything. So we have this, and then using your calculator, you will notice that the answer will be this number. This is the number that we're going to be using in the formula here for I. So let's use it. We can substitute everything. This R is this 950, this I is this number, and this N is 60. So if we substitute in the formula, we have this. It will be a good idea to put this number in the memory of your calculator. In another video, I show you how to do that, how to put the nominal rate of interest in the memory of your calculator, so you can use it here twice in this formula. So let's do it. Yeah. So after using your calculator, you will notice that at the end of these 8 years, so this present value of this annuity will be 38,316.50. So this is the amount that we have here at the beginning of the annuity. And now we are going to be using this amount to compute the present value of this part here. So let's do it. So this 38,316.50 will be the future value of this part. So to find the present value of this period, we're going to be using the formula of present value. So 8 years before, so to find the value of this account 8 years before, we're going to be using this formula of compound interest. Present value equal the future value, 1 plus I to the power negative n. And this I will be then the interest in this period. And we notice that the interest in this period is 5.75% compounded annually. So it will be 0.0575 divided by 1, the periodic rate of interest in this part. And n will be the number of conversion periods in all these years, because there are because we know the time, it will be easy to compute how much is n. So let's type. So for this period, we know the future value, that is this 38,316.50. Let's type here what we know, 38,316.50. We know the nominal rate of interest is 5.75, compounded annually, one per year, and n will be then the total number of conversion period in compound interest. This is n, the total number of conversion period. So it will be a times 1 equal a. Yeah? So this is n, the one that we are going to type here. So we can just make a substitution of everything. So S is 38,316.50, open bracket, 1 plus I, so 1 plus 0.0575 divided by 1. We don't need to type this 1 in this case. Huh? And then to the power negative a. So use your calculator, and you are going to find that this is 24,498.69. What happened if instead of this I, you use the one that we computed before, because we compute an I that was equivalent to this. So this I that was compounded quarterly, that we use it, if you put it here, then you will need to put here the number of quarters in these 8 years. So you put an equivalent rate of interest compounded quarterly, then you need to type here the number of quarters, and the answer will be the same. So this is the amount that Mr. Richards need to deposit here to have this amount 8 years later, and then he will be able to be withdrawing this 950 every quarter during 15 years. So Mr. Richards must invest now 24,498.69 today to achieve his goal. Okay, with this I finish the explanation of this problem. I hope you have found it useful. Thank you.